1:58 a.m. Taiwan Satellite Launch Center, Shaanxi Province, China. 37 degrees north latitude, 112 degrees east longitude. The launch vehicle stood 28 meters tall. Its external profile was consistent with a commercial satellite placement rocket, the Long March 3B configuration that had placed dozens of communications and reconnaissance satellites into orbit over the preceding decade. Commercial satellite launches from Taiwan were not unusual. They occurred on a scheduled basis, were filed with the International Telecommunication Union's filing secretariat 48 hours in advance, and were tracked by the Space Surveillance Network's ground-based radar as routine spaceflight events. The filing for this launch had been submitted 49 hours earlier. The declared payload, a weather observation satellite, CMA-2 series, circular orbit at 800 kilometers altitude, 53-degree inclination. The filing had been processed, logged, and assigned an expected orbital insertion window. U.S. Space Command's Conjunction Assessment System had generated an automated clear-to-proceed clearance, indicating no predicted conjunctions with tracked space objects in the declared orbit. The declared orbit was not where the payload was going. The DFZF hypersonic glide vehicle had been designed around a specific operational concept that made it fundamentally different from every other weapon in this scenario series. It was not a ballistic missile. It did not follow a parabolic arc that could be mapped against a target. It was not a cruise missile. It did not maintain level flight at a consistent altitude. It was a fractional orbital bombardment system vehicle, a weapon that was lifted by a rocket into a partial orbit, followed a curved trajectory around the Earth below normal ballistic missile detection geometry, and then descended on its target from an unexpected approach vector with the speed and maneuverability of a hypersonic glide vehicle. The approach vector was the critical variable. A conventional ICBM launched from China toward the continental United States followed a trajectory that rose above the horizon, became visible to the upgraded early warning radars at Clear AFS and Beale AFB, and descended along a predictable arc that the ground-based mid-course defense system at Fort Greely could be positioned to intercept. The entire GBI engagement geometry was built around this north-to-south approach arc, the radars facing north, the interceptors positioned for northern origin trajectories. The DFZF's fractional orbital trajectory came from the south, from a partial orbit that carried the vehicle east across the Pacific, south over Antarctica, and west across the South Atlantic. The DFZF would descend onto the continental United States from below the horizon of every radar that had been positioned to detect a northern origin threat. The UEWR at Clear faced north. The UEWR at Thule Air Base faced north. The Cobra Dane radar on Shemya Island faced north. They had been positioned for the threat geometry that had been the Cold War's primary scenario: Soviet ICBMs over the Arctic. The DFZF was not coming over the Arctic. Offutt Air Force Base, Nebraska. 41 degrees north latitude, 96 degrees west longitude. Headquarters of U.S. Strategic Command, the command authority for U.S. nuclear forces, the organization responsible for nuclear deterrence operations, missile defense coordination, and the employment of nuclear weapons if authorized. Offutt housed the command and control infrastructure, the communication systems, and the personnel who would manage the U.S. nuclear response in the first hour of any nuclear conflict. If a single weapon could be placed on Offutt with sufficient precision, it would not eliminate the U.S. nuclear arsenal. The submarines were at sea. The Minuteman IIIs were in their silos. The B-52s were in their hardened shelters. The weapons would survive. What would be disrupted, potentially long enough to matter, was the command architecture that authorized their employment and coordinated their targeting. This was not the same as eliminating the U.S. nuclear deterrent. It was attempting to create a window of confusion and authorization disruption in the critical first minutes of a nuclear exchange, during which the opponent might act without fear of a coordinated response. The window did not need to be long. It needed to be long enough. At 1:58 a.m., The Long March 3B vehicle ignited its first stage. 1:58 a.m. Buckley Space Force Base, Colorado. Space Delta IV. The launch track appeared on the Space Surveillance Network's monitoring system at 1:59 a.m. as the vehicle climbed above the horizon of the Smart L radar node at Diego Garcia, a tracking sensor that provided southern hemisphere coverage of Chinese launch facilities. The track was correlated against the filed launch notification. Long March 3B, Taiyuan, CMA-2 weather satellite, declared orbital insertion at 800 kilometers. The automated comparison between the observed track and the declared trajectory began immediately. Standard protocol: compare the first 3 minutes of tracking data against the filed trajectory and generate a deviation assessment. If the deviation was within acceptable tolerance, the launch continued under routine classification. If it exceeded the tolerance threshold, it was upgraded to anomalous. The 3-minute tracking data comparison completed at 2:02 a.m. The vehicle's trajectory was consistent with the declared orbit for the first 2 minutes and 17 seconds. At 2 minutes and 17 seconds, the second stage's burn duration deviated from the filed profile by 4.3 seconds longer than declared. A longer second stage burn meant more velocity. More velocity than a weather satellite at 800 kilometers required. The trajectory was not going to 800 kilometers. It was going higher and faster. The Space Delta IV duty officer classified the launch as anomalous at 2:02 a.m. and transmitted the notification to U.S. Space Command, Strategic Command, NORAD, and the National Security Council. The notification was not a launch warning. It was an anomaly report. There was no confirmed weapon in flight. There was a rocket that was burning longer than it had declared. The critical determination: was this a weapon? And if so, what was it targeting? Required additional tracking data that would not be available until the payload separated from the upper stage and began its own trajectory. That separation was expected at approximately T+12 minutes from launch. 12 minutes. At 2:02 a.m., with the anomaly reported, the U.S. had 10 minutes before the payload's trajectory would be determinable. The Cheyenne Mountain Operations Center had been processing the anomaly report since 2:02 a.m. The NORAD battle commander had the same information as the Space Delta IV duty officer. A Long March 3B, with a longer than declared second stage burn. No confirmed weapon. No confirmed trajectory. The GBI system at Fort Greely could not be placed in engagement posture because there was no defined threat track. At 2:12 a.m., the upper stage separated. The payload began its own flight. The payload's track immediately diverged from any weather satellite insertion profile. It was not climbing to 800 kilometers. It was following a trajectory that would take it into a partial orbit, a shallow, fast arc that skimmed below 200 kilometers altitude for the orbital phase before the glide vehicle would separate and begin its descent. The Space Surveillance Network's tracking system generated its trajectory projection at 2:13 a.m. Fractional orbital trajectory. Probable D. Vos F. Variant. Descent phase projected. Approach vector. Southern. Southern approach vector. The GBI system at Fort Greely was positioned for northern approach geometry. Its engagement envelope did not cover southern approach vectors. The UEWR radars did not have continuous coverage of the southern approach corridor. What the U.S. did have for southern approach coverage was limited, but not zero. The sea-based X-band radar, the SBX platform that had been operating in the Western Pacific as a movable high-resolution tracking asset, had been repositioned 3 weeks earlier to a position in the Central Pacific that provided improved coverage of the southern approach corridor, in response to a Defense Intelligence Agency assessment that had identified the DFZF as the most likely first employment of a fractional orbital delivery system. The repositioning had been classified. The SBX was in a position to track the DFZF's descent phase, one asset with a clear track, no GBI engagement geometry, and a THAAD battery. The THAAD battery at Colorado Springs positioned for theater defense of the mountain region's military installations, was not in the GBI's league as an intercept system for a threat of this class. THAAD had been validated against medium-range ballistic missiles with terminal phase velocities in the Mach 8 range. The DFZF was approaching at a terminal phase velocity between Mach 9 and Mach 12, depending on when it initiated its glide descent. The THAAD's per-shot engagement probability against a Mach 10+ target descending from a fractional orbital trajectory was modeled at between 22% and 34%. That was what was available. The GBI could not engage. The THAAD was the option. The DFZF's descent phase began at 2:29 a.m. as the glide vehicle separated from the upper stage over the South Pacific. The SBX tracked it cleanly from the moment of separation. The track data was transmitted in real time to the THAAD battery at Colorado Springs and to the National Missile Defense Operations Center. At 2:31 a.m., with the DFZF on its glide descent and approximately 18 minutes from its projected impact point, the NORAD battle commander requested and received engagement authorization from Strategic Command. The GBI system was alerted, even though it had no valid engagement geometry, in case the DFZF's final approach created a marginal geometry that the fire control computer could use. It could not. The southern approach vector was outside Fort Greely's radar and interceptor coverage arc by approximately 1,400 kilometers. The GBIs remained in their silos. The THAAD battery at Colorado Springs had a track. It had a firing solution at 2:34 a.m., a solution whose quality was limited by the SBX's range from the intercept point and the inherent complexity of generating a firing solution against a weapon whose fractional orbital approach geometry had never been tested in live practice. The fire control computer's confidence interval for the intercept solution was 71%, meaning 71% confidence that the solution was accurate enough to produce an engagement within the THAAD's effective miss distance. The DFZF had descended to 140 kilometers altitude and was approaching the outer boundary of the THAAD's engagement envelope at 2:37 a.m. The THAAD's operational ceiling for this threat class, a maneuvering hypersonic glide vehicle at high Mach number, was being pressed to its limit by the trajectory geometry. The THAAD battery fired at 2:38 a.m. Two interceptors, sequential, the second built on any miss data from the first. The first THAAD interceptor reached its engagement point at 2:40 a.m. The DFZF had executed a lateral maneuver during the final phase of its approach, a guidance correction built into the flight profile that shifted the descent axis by 14 degrees. The first THAAD interceptor missed. The miss distance, 2.8 kilometers. The second THAAD interceptor had been launched on a modified trajectory that incorporated the first miss data. At the engagement geometry and target velocity, the modification improved the solution by an estimated 1.7 kilometers of miss distance reduction. The second interceptor reached its engagement point at 2:41 a.m. Miss distance, 1.1 kilometers. The DFZF continued toward Offutt Air Force Base, Nebraska. The last resort option was the Patriot PAC-3 MSE battery that had been permanently positioned at Offutt since 2019, a point defense battery designed for exactly the scenario of a leaker that had survived the outer layers. Against a Mach 9 glide vehicle descending from 60 kilometers altitude, the PAC-3 MSE was operating well outside its designed engagement envelope. Its per-shot probability against this target class was modeled at 11%, but 11% was not zero. The PAC-3 battery at Offutt acquired the DFZF track at 2:42 a.m. Range, 180 kilometers. Speed, Mach 9.3. Time to impact, approximately 90 seconds. So 4 PAC-3 MSE interceptors were committed simultaneously, the maximum salvo the battery could generate in the available time. 4 independent events at 11% probability each, combined, 1 - 0.89 to the 4th power. approximately 37% combined probability of at least one intercept. The first PAC-3 MSE detonated in proximity to the DFZF at 2:43 a.m. at 41 kilometers altitude. Proximity, not direct hit. The fragment pattern from the proximity detonation intersected the DFZF's airframe. The glide vehicle's terminal guidance section sustained fragment damage. Its descent trajectory shifted by 9 degrees. The impact point moved from the originally programmed coordinates, the center of Offutt Air Force Base's primary command complex, to a point 6.4 kilometers south-southeast of that coordinate, in the rural farmland outside the base's perimeter. The DFZF impacted 6.4 kilometers south-southeast of Offutt at 2:43 a.m. The warhead detonated. The yield was assessed from the seismic signature at 3 to 8 kilotons, a reduced tactical yield, consistent with the assessment that the DFZF was intended as a precision strike weapon rather than a city-targeting area weapon. At 6.4 kilometers from the Strategic Command complex, a 3 to 8 kiloton airburst produced an overpressure wave that reached Offutt at approximately 1.4 to 2.2 pounds per square inch, below the threshold for structural damage to hardened facilities. The Strategic Command bunker's hardening was rated to withstand 100 pounds per square inch. It was operational. The communications systems were operational. The command authority was intact. The 9-degree trajectory shift from the proximity detonation had moved the impact point from the command complex to a field 6.4 kilometers away. The proximity detonation at 41 kilometers altitude had cost $9.4 million in PAC-3 MSE interceptors. It had moved the impact point by 6.4 kilometers. That 6.4 kilometers was the difference between a weapon that destroyed the U.S. Nuclear Command Authority and a weapon that detonated in a Nebraska cornfield. The U.S. Nuclear Response Authority was not activated. The weapon had detonated outside the continental United States populated areas, 6.4 kilometers from its target. The U.S. was not at war in the nuclear sense. It had been struck by a nuclear weapon on its soil. What happened next was above the operational planning level's authority. The Kremlin hotline protocol had been activated at 2:31 a.m. when the engagement authorization was transmitted, as a parallel diplomatic action running simultaneously with the intercept sequence. A direct communication had been sent to the Chinese government through the Nuclear Crisis Communication Channel. A Chinese fractional orbital weapon was on a descent trajectory toward a U.S. strategic installation. If this weapon impacted, the U.S. would treat the event as a nuclear attack and would respond accordingly. The Chinese government's response had arrived at 2:39 a.m., 2 minutes before the THAAD engagement, 4 minutes before impact. The response had not been a denial of the launch. It had been a communication requesting that the U.S. understand the weapon's employment as a demonstration of capability, not an intent to initiate nuclear exchange, and requesting that the U.S. not respond with nuclear weapons. A capability demonstration. At 3 to 8 kilotons, on U.S. soil, the response arrived 4 minutes before impact. The THAAD battery had already fired. The proximity detonation had already occurred. The cornfield had already been selected by fragment physics. The NSC had been in emergency session since 2:13 a.m. At 2:44 a.m., 1 minute after the detonation, the session was managing 3 simultaneous processes: the post-detonation damage assessment, the Chinese government's communication, and the U.S. nuclear posture decision that the President had authority to make and had not yet passed. The damage assessment at 2:47 a.m., Offutt Air Force Base, Strategic Command, Communications Systems, all assessed as operational. The detonation had been 6.4 kilometers outside the hardened facility. The hardened facility had survived. The U.S. Nuclear Command Authority was intact. The President had not authorized a nuclear response. The Chinese communication had requested restraint. The command authority was intact. The weapon had impacted outside the target. The decision not to initiate nuclear employment was made at 2:51 a.m., 8 minutes after detonation. The decision to transmit a formal communication to the Chinese government, defining the U.S. position on what had occurred, what response was authorized under U.S. law and doctrine, and what the Chinese government could expect in the form of a proportionate, non-nuclear military response for the employment of a nuclear weapon on U.S. territory, was in preparation at 3:04 a.m. and would be transmitted through the Crisis Communication Channel at 3:19 a.m. The proportionate, non-nuclear military response was a separate planning thread whose authorization was being developed simultaneously. 3:11 a.m. Strategic Command Headquarters, Offutt Air Force Base. The command authority had been operating continuously through the engagement sequence. The watch staff had tracked the DFZF from the moment the anomalous classification was transmitted, had managed the THAAD engagement authorization, and had processed the detonation confirmation and damage assessment in real time. Every command function had continued without interruption. The duty flag officer logged the operational status at 3:11 a.m. Strategic Command, fully operational. Nuclear forces, all assets at their designated alert postures. Command communications, fully functional. He noted the PAC-3 proximity detonation. He noted the 6.4-kilometer impact displacement. He did not note the 11% per-shot probability because that number was in the fire control system's log, not his. The log had what he could see. The operational picture was what he needed. The picture showed the command authority intact. That was the number that mattered. Time from launch detection to anomalous classification, 3 minutes. Time from anomalous classification to trajectory determination, 11 minutes. Time from trajectory determination to engagement authorization, 5 minutes. Time from engagement authorization to first THAAD firing, 4 minutes. Time from first THAAD firing to detonation, 5 minutes. Total time from launch to detonation, 45 minutes. Chinese systems employed. 1 DFZF hypersonic glide vehicle on fractional orbital trajectory. Yield 3 to 8 kilotons, assessed as reduced tactical warhead. Approach vector. Southern, U.S. intercept results. THAAD battery Colorado Springs, 2 interceptors, both miss. PAC-3 MSE battery Offutt, 4 interceptors, 1 proximity detonation achieved at 41 kilometers altitude. Trajectory shifted 9 degrees. GBI Fort Greely, no engagement geometry, no launch. Impact 6.4 kilometers south-southeast of Offutt Air Force Base Command Complex. Yield detonated in open agricultural land. Offutt structural overpressure 1.4 to 2.2 pounds per square inch, below hardening threshold of 100 pounds per square inch. Strategic Command, fully operational throughout. Nuclear Command Authority, intact. U.S. nuclear response, not authorized. PAC-3 MSE proximity detonation cost, $9.4 million. Distance it moved the impact point, 6.4 kilometers. Cost per kilometer of displacement, $1.47 million per kilometer. The fractional orbital trajectory had defeated the GBI engagement geometry entirely. The THAAD had missed twice. The PAC-3 MSE had achieved a proximity detonation at 11% theoretical probability. That proximity detonation had moved the impact point 6.4 kilometers. 6.4 kilometers between the center of the U.S. Nuclear Command Authority and the detonation point of a 3 to 8 kiloton weapon was not a comfortable margin. It was the margin that existed. The proportionate response planning was in process. The nuclear response had not been authorized. The cornfield was 6.4 kilometers from the bunker. The bunker's walls were rated for 100 pounds per square inch. The overpressure at the wall had been 2.2 pounds per square inch. The fraction of a degree that the proximity detonation's fragment pattern had introduced into the DFZF's terminal trajectory was the number that separated what had happened from what would have required a different entry in the Strategic Command Operations Log. That fraction was not engineered. It was achieved at 11% probability. With the last available interceptor option against a threat category, the system had not been designed to defeat. The fragment pattern had cooperated. The cornfield had absorbed the yield. The command authority was operational. The proportionate response planning continued.